Okay, so hashing is nothing but it is a process of mapping large amount of data into the smaller table by using hash function. Okay, so this mechanism I just explained over here. So hashing is nothing but it is a process to store or search the large amount of data into the particular small tables with the help of hashing. Okay, so here whenever we consider the hashing, then there are the two types of the hashing. The first one, that is static hashing. Static hashing. And second, that is dynamic hashing. Okay, so let's see one by one what is meant by static hashing and what is meant by dynamic hashing. Okay, so before proceeding to the static hashing and dynamic hashing, we just see what is meant by hash table. Okay, so these are the basics related to hashing. So hash table is nothing but it is a data structure in which keys are mapped to the array location by using hash function. Okay, so here this is the particular relationship between the particular key and the hash. So suppose if you are having the storage, so suppose I am having this particular storage and I want to just store this particular whatever the keys which are present to the particular specific location. So these are the locations. So these are the locations, nothing but hash tables. And we want to just store these particular keys to the hash table by using the hash function. Okay, so hashing is nothing but we have to just store the data into the hash table by using hash function. Okay, so hash table is nothing but it is a data structure which is used to store the particular data. So there is a direct link. So hash table is a data structure in which keys are mapped to the array position by using hash functions. So there is a direct link between the hash table and keys. And these particular routes that are forwarded through the calculation of hash function. Okay. So for example, suppose this one key. So one key is stored inside the first location. Third key is stored inside the third location. Fourth key is stored inside the fourth location. So these are the particular keys which are available and which are stored in this particular array from 0 to 9 locations. Okay, so this is nothing but your hash table. These are the keys and these are the roots is nothing but your hash functions. Okay. Now, in this particular example, let's say K1 is stored inside the 0th position. K2 is stored inside the third position. Again, similarly, there is overlapping. That is K6 also stored inside the third position. Similar cases happen for K5 and K7, which is stored inside the 9th position. So such overlapping or collision, we have to avoid it by using the mechanisms inside the hashing function. Okay, so at one location, we have to represent a single data. So hash function is nothing but what is meant by hash function? Hash function is a mathematical formula which is used to produce the integer number which can be able to find the index inside the hash table. Okay, so main aim of the hash function is the element that should be relatively random, uniform, and uniformly distributed and unique. Okay, so these are the particular properties that is low cost, that is it requires the very small amount of calculations. Determinism means whatever the value of that particular hash value, that must be generated same with given input. So if one index is there, every time it will generate the same value. And uniformly means each and every time we have to generate each or single value throughout the distribution of the index. Okay, so which are the different hash functions? The first one, that is division method. So division method means what? Here, whenever we are having the particular keys, then we can just apply the modulus to that particular key. Okay, so for example, suppose h of 1, 2, 3, 4 is equal to, here we just apply the 1, 2, 3, 4 mod 97. So our index we got is 70. Okay, so we can just store the particular data 1, 2, 3, 4 at the 17th location inside the particular array from 0 to 100. Okay, so similarly 5642, so 5642 mod 97 is equal to 16. So it just apply the modulus. So modulus means what? We can just have the reminder inside my number. So for example, suppose I just having the number 11 mod 10. So what will be the reminder? 1. Okay, so whatever the 11 upon 10, so it's whatever the reminder. So मराठीत आपण त्याला बाकी म्हणतोय. Okay, so reminder is 1. So this particular reminder we can able to calculate inside the division method. Okay, so inside the division method, we have to divide the x by m and then uses the reminder obtained. So hx is nothing but it is a reminder which is obtained with the help of the x upon m. Okay. So you can just calculate the modulus inside the division methods. Then second, that is multiplication method. So multiplication method includes the formula that is m k mod 1. Okay, so here we have to take the particular, so choose constant a. So here we extra take the constant a. So what will be the value of a? The value of a in between 0 to 1. So it may be 0.1, 0.2, 0.3, 0.4 depending on user. Okay. So to calculate the particular mod, we just take the constant a, multiply the constant key by a and extract whatever the functional part k and multiply the result by the size of the particular table, and we can just apply the mod 1. Okay, so here suppose I just take the value as 1, 2, 3, 4, 5 and I want to calculate the hash key for this particular value. So I just take 1000. So 1000 means what? It is a m, that is whatever the size of m, size of hash table. So hash table size in bracket whatever the number into whatever the constant a. So constant a is taken as 0.618033 mod 1. So whatever the calculations of this is 617.385. So you have to just ignore the fraction part. You will get the answer as 617. Okay, so this is the particular calculation which is required for storing the particular number inside the hash table of size 1000. Then mid square method means what? Here we have to calculate the square root of the square of that particular number, and we have to just take the middle part from the square. Okay, so for example, suppose So suppose I am having the number as k is equal to 1, 2, 3, 4. So its square is 1522756. Okay. So we have to just map the particular number from 100 location. So we require the 2-digit number. So we have to just calculate the middle part. So here there are the, how many numbers are there? 1, 2, 3, 4, 5, 6, 7. Okay. So इथं किती नंबर आहेत? 7 number आहेत. So we have to calculate the middle. So 7 upon 2 is equal to 3. Okay. So after 3 number, we have to take the 2 numbers. So I just write this particular, then only you can able to understand. Okay. So 1, 2, 3, 4 square. Okay. So after taking the square is 1522756. So from this particular square, these are the total 7 digits. So 7 upon 2 that is 3. So after 3, we have to calculate the particular number. So number is 27. So we just have the output as 27 over here. Then suppose we just take the another number. That is 5642. I just copy this. Okay. So suppose I just take another example, that is 5642. Now its square is 318326164. Okay, so this is the particular number. So how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8. So total 8 digits are there. Upon 2, that is 4 digits. So we have to consider the number from 4 digits. So 1, 2, 3, 4. So these are the two numbers which we want to consider. So we have to just take the key as 21. Okay, so inside this particular mid square, we have to calculate the square and we have to consider the mid number inside that particular square so that we can calculate the particular key where we can just store the particular number. Okay. So this is related to the mid square method. And last method related to the hashing is folding method. So folding method means what? Here we have to just fold the particular numbers into the 2 digits except the last digit. Okay, so whatever the number we have, we can just fold that particular number into the 2 and calculate the sum. Okay, so suppose this is the particular problem. So I just copy this particular. Okay, so suppose I am having this particular number, that is 5678. Now I want to just, so this is the particular number to be stored on hash table. ओके, सो आपल्याला काय करायचं आहे तर हा पर्टिक्युलर नंबर हॅश टेबल मध्ये स्टोअर करायचा. तर माझे हॅश टेबलचे लोकेशन्स किती आहेत तर 100. सो आय एम हॅव्हिंग द पर्टिक्युलर लोकेशन फ्रॉम 0 to 100. Okay, so this is the 0th location up to 99. Okay, so my locations are 100. So what I want to do, I have to just apply the folding method. So folding method means what? Here we have to just fold the particular number into the two parts. And if only one is remaining, then we have to just consider that one. And whatever the additional number, we have to ignore. Okay. So here we have to just divide the particular number into two parts. So 56 plus 78. So what is the number? That is 134. So whatever the extra additional bit, so this is the additional bit. So we have to ignore this and we can just consider as a 34. And we can just store this particular number at the 34th location as like this 78. Okay, so this is nothing but the folding method. Again, we just consider the another number, that is 312. So 321. So again, two digits and one digit. So 32 plus 1, that is 33. So you have to just store the particular number into the 33. So here I can just store 321. Again, we just take the number 3, 4, 5, 6, 7. So we just divide the particular number into the two digits parts. So 34 plus 56 plus 7. So its number is 97. So you can just store the particular data at the 97. So 3, 4, 5, 6, 7. So in this way, we can able to store the particular data into the specific location. So all these particular things are given in the problem statement. So given the hash table 100 location, calculate the hash value by using folding method, and keys are this. Okay. So these are the particular keys which need to store inside the hash table. So we have to just find the particular index. So index can we just find by using the hash tables. Okay. To store the data into the hash table so these are the particular 4 functions related to the hash functions. Okay. So which are the 4 functions or 4 methods? First one, that is we have to just use the division method. So reminder is used as a key. Then multiplication method means we have to just take the constant a and apply the mod 1 to that particular constant so that we can calculate the location. Then mid square means we have to calculate the square of that particular number and just take the mid two digits within that particular number. And inside the folding, we can just divide the particular number into the two digits and we can get the particular number. Okay, so in this way, we can able to just use the different hashing techniques. So there are lot of techniques which are available inside the programming. So here inside the book, we are just having the 4. Okay. The next concept, that is secure hash functions. So secure hash functions or secure hashing algorithm is basically apply inside the cryptography for just securing the particular number. Okay. So inside the particular cryptography, okay, so inside the cryptography, we can have the secure hash functions and we can able to encrypt the particular data by using hash function and we can just store the encrypted data. Okay, so basically suppose this is the particular data, that is grass is a particular secure data is a plain text. So we can just want to just secure this particular data by just applying the hash function. We can just secure the data in the ciphertext format. Okay. So such thing also able to apply by using hashing. Okay. So inside the hashing, the most important issue that is collision resolution or overflow handling. So collision resolution means what? Suppose we just consider the earlier example. Okay. So consider this particular example. In this particular example, this K2 is pointing to the third key, as well as this K6 also pointing to the third location. Okay, so there is a collision. That is, two keys are pointing to the single location. So there is a collision because at one single location, only one number is stored. So what about the another number, which is pointing to the same location? So this is nothing but the collision. That is collision to store the particular data. So such mechanism we have to just design or develop to avoid the collision or to resolve the particular collision. So it is also called as overflow handling technique. Okay. So there are the two most popular methods for resolving the particular collision. So first one is called as open addressing and second one is called as chaining. So open addressing is also called as close hashing and chaining is also called as open hashing or close addressing. Okay. So let's see one by one. So open addressing. So open addressing is a particular technique where we have to just search the particular location by just probing the particular table fields so that we can able to find the empty location for the records which are collide with each other. Okay. So इथं काय करायला लावले आपण तर आपण एम्प्टी लोकेशन सर्च करणार. कशासाठी? तर आपली जर टू कीज एकाच सेम लोकेशनला जर लोकेट करत असतील, सो त्या केसमध्ये आपल्याला नेक्स्ट एम्प्टी लोकेशन सर्च करायचं. So in that particular case, we can able to apply the open addressing technique. So inside the open addressing technique, we have to just search for the particular key by using the probing. So probing is a mechanism which will we just find the empty memory locations inside the hash tables. Okay. So first one, that is linear probing. So inside the linear probing, we have to just apply the formula. So this is the particular formula which we want to apply. So HK plus I mod M. So what is mean by HK? What is mean by I? What is mean by mod M? Okay. So HK is nothing but it is a hash key plus I means it is a probing. So initially probing is 0. That is, there is no resolution or there is no collision. If collision is occurred, the value of I is increases by 1. If it is not resolved, it will increase by 2. If it is not resolved, it will just increase by 3 and so on. And M includes the locations inside the hash tables. Okay. So let's see the example related to the probing. So I just consider this particular example. Okay, so this is the particular example where what is my requirement? Hash table having the size 10. So here hash table size is given as 10. So our M is equal to size of hash table is equal to 10. Then what is meant by HK? HK is nothing but the keys. So K is nothing but the keys to be stored in hash table. Okay. Then, so we have just seen M, we have just seen K. So what is the formula we want to apply? We have to just see the formula, that is HK is equal to H of K plus I mod M. Okay, so this is the particular formula which we want to apply over here. Okay, so H of Ki is equal to Hk plus I mod M. Hk plus I mod M. So this is the particular formula which we want to apply. Formula. So I stands for the probing constant. Default is 0. Default is 0. And when collision occurs, increment by 1. Okay, so these are the most important things inside my example. Okay, so this is my hash table where I want to just store the particular keys. Okay, आता हा particular hash table आहे, त्याची साईज किती आहे 10. So 0 to 9. आता ह्याच्यात काय करायचं आहे, तर मला ह्या कीज इन्सर्ट करायचे, दॅट इज 72, 27, 36, 24, 63, 81, 92 and 101. ओके, आता मी काय करणार, पहिल्यांदा 72 घेणार. ओके, सो आय जस्ट कन्सिडर 72 and I just calculate the value by using this particular formula. So 72 plus I value initially is 0 mod M. So what is the value of M? 10. Okay, so same thing which is given inside the particular example. So 72 mod 10 plus 0 mod 10. Okay, so here I'm just taking the hash function over here. So instead of taking the 72, I just take the hash function over here because the value is HK. So I just take the hash function, that is 72 mod 10. And again mod. So instead of that particular symbol, I just take the symbol. Mod 10. Okay, so 72 mod 10 means what? Reminder is 2. So 2 plus 0 mod 10 means 2. So we have to just store the particular content, that is 72, inside the second location. So here I want to just store that particular 72. So instead of here I just store the 72. So this is how I just insert the first. Then again I just go to the second number, that is 27. So 27. So 27 mod 10 plus 0 mod 10. Okay, so it's 7. So we have to just insert the particular number into the 7. So 27 we have to insert into the 7 digit. Again we are having the 36. So we just 36. So 36 mod 10 plus 0 mod 10. Okay. So number is 6. So we just store the particular data into the 6. That is 36. Similarly 24. So 24 that is here, fourth location. 63. That is third location. 81. That is first location. Now the problem is occurred. Now what is our requirement? 92. Okay, so 92 means we can get the remainder 2 and we want to just store in the second digit. But here the collision get occur. Okay, so collision is occurred because already this particular location is occupied with 72. Okay, so inside the probing, we have to just search for the next empty location. Okay, so how to search? By just increasing the value of this particular 0. Okay, so let's see how. So I just increase the value of this particular, since it is a collision, because number that particular position is already occurred. So we just increase the value of I is equal to 1. Okay, so 92 mod 10 plus 1. So this is the value of I. Okay, mod 100. Okay, so 2 plus 3, 3 mod 10, that is value is 3. So third location is already occupied. So again we just increase the value of I by 1. So 2. So whenever we just take it as 2, then 2 plus 2, that is 4. So here value is 4. So again fourth location is occupied. So again we just increase the particular value of I by 1, that is I is equal to 3. So now 92 mod 10 plus 3 again mod 10. Okay, so now 2 plus that is 5. We can get the 5 as answer. So 2 plus 3 and mod 10 means 5. So fifth location is open. So here is our fifth location. So here we just insert the 92. Okay, so this is the particular mechanism which we want to apply inside the probing. So probing means what? We have to just select the next empty location and we have to just store that particular number into that empty location. Okay, so same thing which can be applied for the 101. So 101, that is one location. So it is by default occupied. Second location is occupied. Third, fourth, fifth is also occupied. 6, 7 is also. So it will just store that particular 101 inside the 8th location by just using the probing mechanism. Okay, so same thing. It will just given over here. Okay, so 92 here probing is given as 3. So you might observe this particular 3. So it will just store at the 5th location. And for 101, it will just store at the 8th location. Okay, so it will just given as location 8, which is vacant and can be used to store the particular value. So this is called as linear probing. So linear probing, inside this particular linear probing, this is the particular formula which is used to calculate the hash index. Okay, so hash function is used to calculate the index, and we have to just use this much iterations to calculate that particular values. Clear? Just tell me.
Yes, sir.
Sir.
Okay, so here these are the particular key concepts, that is M, K, and I. Then only you can able to understand the particular example. Else not. Okay. So if you are not understanding this M, what is M, what is K, and what is I, then you are not able to solve that particular example. Okay. So our intention is to just clear that particular concepts. Then here we just move next. That is another mechanism. So C code is also given inside the book. Next one, that is quadratic probing. So quadratic probing, what is the difference between that our linear probing and quadratic probing? Inside the quadratic probing, it will add the two constant, that is C1 and C2. Okay, so extra values that are calculated to resolve the particular collision. So C1 constant and C2 constant we have to just take, and we have to just resolve the particular collision. Okay, so here consider the particular example. So I will just only solve one step. You can just try it out on the steps at home. Okay. So here I just copy this particular example. And paste it. Okay. So here again, what is my requirement? My hash table value is 10. So what is my constant of M? M is equal to 10. Okay. Then using the quadratic probing, insert the different keys. So keys कुठल्या आहेत आपल्या? Keys is equal to K is equal to 72 एक आहे. Then 27, 36, 24, 63, 81 and 101. आता इथं मला काय दिलंय की C1 ची व्हॅल्यू आणि C2 ची व्हॅल्यू कॉन्स्टंट व्हॅल्यू दिल्या तिथं. ओके, सो C1 is equal to 1 and C2 is equal to 3. Okay, and my by default probing value, that is I is equal to 0. Okay, so unless and until collision is occurred, my I is remains 0. So I want to apply this particular formula. Okay, so this is the particular formula which I want to apply throughout my calculation. So this is the particular formula for hash function. Okay. Now we just take the value as 72. So key is equal to 72. So we have to calculate the particular value by using this particular formula. Okay. So HK. So HK means what? 72 mod 10. So this is the HK plus C of I. So C of I means what? C1 value is 1 into I means 0. So 72 mod 10 plus 1 into 0 plus C2 of I. So here I square. So 0 square is 0. So 3 into 0. Again, whole number that can be just mod by 10. Okay. So what will be the answer over here? Here the value getting 0 here value getting 0 and here 2. So 2 mod 100, that is 2. Okay, so here we can get the h of 72 with the 0th probing is 2. Okay, so we have to just store the particular data at the second location. Okay, so this is the particular probing. So what are the extra things which are added? Extra thing is C1 and C2. Okay, so this is I and this is the I square. So only these are the particular, only change in the formula only. There is nothing change in the mechanism. Same thing which we want to apply inside the program. Okay, so this is how we can able to calculate the quadratic probing. So quadratic probing, just change in the formula, nothing else. So in this particular formula, C1 of I and C2 of I square is added. That's it. And by using this particular formula, you can able to just calculate the particular values. Okay, so here 2 is calculated, then here the different numbers are inserted. So I will just show the probing. Okay, so for inserting this particular key, that is 101, we require the probing. So here first atom we just have, and we just insert the particular data at the fifth location. So in this way, we can able to just apply the quadratic probing. So whatever the drawbacks inside the linear probing, that is 3 times it requires the particular probing to be increases. But inside the quadratic probing, only one time we require this particular probing. Okay, so this is the little bit advanced technique for just calculating the particular location to store the particular data. Okay, so this is called as quadratic probing. So again, double hashing means what? Double hashing uses the one hash value, then repeatedly step forward and interval until empty location is occurred. So interval is decided using a second independent hash value. So it is called as double hashing. Okay, so इथं दोन हॅश फंक्शन वापरलं. h of k प्लस नुसता i आपण म्हणत होतो, त्याच्याऐवजी i of h of k mod m. ओके, सो हा फॉर्म्युला जर बदलला तर तुमचं टेक्निक बदलते. Okay, so whatever the calculations related to the hash functions, if formula getting changed, your technique get changed. So these are the particular 3 techniques which are included under this particular concept called open addressing. Okay, so open addressing च्या under 3 technique आहेत. One is linear probing, second one is quadratic probing, and third one, that is the double hashing. Which is also called okay, so double hashing. So its example is similar, that is only change in the particular formula. So all the calculations that are given over here, you can go through that particular calculations so that you can easily get the particular concept. Again, fourth technique, that is rehashing. Okay, so what is the use of rehashing? When hash table become nearly full, the number of collision increases, thereby degrading the performance of the insertion and searching. So in that particular case, we have to just option to create the new hash table with size double of ओरिजिनल हॅश टेबल. ओके, इथं काय नवीन सोल्युशन आलं की when there are the number of collisions that are occurred increases, we have to just double the size of hash table. Okay, so initially hash table size जर 10 असेल, then we directly double that particular size, that is 20. Okay, so here they are just giving initially the hash table having 5 locations, that is 0, 1, 2, 3, 4, 5, 4 up to 4. If the particular size or the particular probing is increases or collision is increases, they have doubled the particular size, that is 0 to 9. So they are just increasing the 5 into 2, that is 10 locations. So they are, that particular locations are situated from 0 to 9. So they are just increasing the double the particular size. So in this way, we can able to just apply the rehashing. So inside the rehashing technique, we can able to double the particular size of the hash table. And again, we can just able to store the particular data. So this is related to the first technique, that is, so for avoiding the collision, we are having two techniques. One is open addressing and second one, that is chaining. So open addressing we have just discussed. Open addressing includes linear probing, quadratic probing, then double hashing and rehashing. So these are the 4 techniques which are included under the open addressing. Then let's see chaining technique. So chaining technique, we just use the concept of linked list. Okay, so inside the chaining or open hashing method, each location in hash table stores the pointer to the linked list. And if there is a collision, then we have to just extend the particular pointer to the next location, which extend the pointer to the next location and so on. So the linked list concept that can be just applied to store the multiple atoms in the same location. So this is nothing but the chaining. So same concept, same example, it is just shown. So here m is equal to 9 because we are having the locations 0 to 8. So value of hash memory is 9 locations. So 7 mod 9, that is 7. So it will just store the particular data into the 7th location. Again 6 location, again 4, 5 and so on. Okay, so in this way we can able to represent the particular data. So this whole example gives that particular contents. Okay, so this is the key differences between the open hashing and closed hashing. So open hashing means what? It is also known as closed addressing. So keys are stored in the linked list attached to the cells. Each index maintains a list of the keys that are stored in the same index, and keys are linked to each other. And here two keys, two hash keys to be same index, then both are inserted in the linked list fashion. So it is efficient to maintain the large number of records. Closed hashing means what? It is also known as open addressing. Keys are stored directly to the index of the hash table. So linked list is not used. The index at which the key is actually stored may depend on the keys. So whatever we just discussed, the different probing methods, double hashing, rehashing. So these are included under the closed hashing. So small number of records that can be efficiently stored by using this particular indexing. Okay, so these are the particular techniques related to the static hashing. Okay, so static hashing having the 2 types. First one, that is that is collision avoidance type. That is first one, that is open addressing, and second one, that is closed addressing. So inside the open addressing, we are having the 4 techniques. linear probing, quadratic probing, rehashing, and double hashing. And inside the open hashing only we have to just only one technique, which is known as the name itself, that is chaining technique, and the linked list is used to store that particular chains. The next, that is dynamic hashing. So what is the motivation related to the hashing? So inside the static hashing, whatever the memory locations that are fixed. So suppose we want to just store the data into the 0 to 99 memory locations. So 100 records we can keep in that particular hash table. But suppose I am having only two keys. So two keys require the two locations. Why there is wastage of that another 98 record memory? Okay, so such wastage we can avoid by just using the dynamic hashing query. So dynamic hashing is used and it will just allocate the memory depending on requirement, and it will just shrink that particular memory when requirement is not there. Okay, so here dynamic hashing just dynamically increase the size and it will just shrink the size whenever it is not required. Okay, so here inside the dynamic hashing there are the two types: dynamic hashing using directories and dynamic hashing without using directories. Okay, so let's see one by one. Okay, so dynamic hashing using the directories, consider following example. Okay, so this is the particular example where we can use the hashing. So here keys are reference and hash functions are reference. So A0, this particular hash keys, and we have to just store this particular numbers. So here, whatever the keys we have, so which are the numbers, for example, 21, 71. So here inside the dynamic hashing, we have to convert that particular number into the binary constant. Okay, so A0 is converted into the 100,000. And we have to just consider the last two digits of that particular number for storing the particular number into the directory. Okay, so this is how. So suppose we are just having the directories like this 0001, 10, and 11. So inside this particular directories, whatever the last two digits we have. Okay, so I just take this particular example. Okay, so I will just paste this particular content. Okay, so here inside this particular number, suppose I want to just store this particular whole keys. So whatever the keys which are located over here, I want to just store. So first step, I have to convert it into the binary constant and consider the directory that is R number of bits. So last two digits initially we consider, or 3 digits or 4 digits depending on your records. Okay, so here I just consider 0001, 0001, again 1011. So depending on that, I can able to okay, I can able to just store the particular data. Okay, so whatever the 00, A0 and B0 that are stored inside the 0 location. Then A1, B1, then C2, C3 are stored in this particular location. Okay, but suppose I want to just insert again new number. Okay, so suppose I want to just insert this particular C5. So C5 having this particular constant. So last two digits is 01. So 01, that is two locations are already filled. So here we are not able to fill the third location. So in that particular case, we have to increase the size of this R to the 3. Okay. So instead of this particular 00011011, we can just write 000. So whatever the digital constant logic we just seen in the digital logic circuit. So same thing we can apply. So here we just increase the size by 4 more, and we just take it as 8. So here size is 4, here size is 8. Now we have to consider these last 3 digits and we can just allocate over here. So same thing which can be just given inside this particular. Okay, so here size increases and it will just store the data. But again, suppose this particular key is inserted. So 3 locations are required. So if that particular locations are again full, we have to just increase the size by 4. So there are the 16 locations which are available, and we can just map that particular 16 locations to again this particular structure. So in this way, we can just have the directories and we can just map the particular numbers to the directory by using the binary constants. Okay, so last 3, last 4 or last 2 digits we can able to just consider to allocate the indexing. And the next one, that is second technique, that is directory-less dynamic hashing. So inside the directory-less dynamic hashing, we are not using the directory. Here, we just use the linked list to just map the particular number. Okay, so if it is overflow, then we have to just consider the increase in the particular digits. So initially it is 0001 1011. If this particular field is not enough, then it will just increases to 000 to 111. Again, if it is not enough, then it will just increases to the again another level, that is 000 to 1111. Okay, so new pages are inserted and we can able to just add the extra data within that particular pages inside the particular directory less dynamic hashing. So whenever you are just going through this particular concept, you can easily understand the particular examples. So very simple concepts are there. So in this way, we can just having the different applications where we can use this particular thing or hashing. So hashing is basically used in the by using the different languages. So Python is mostly used or JavaScript is used. So inside the databases, we can use the hash. Inside the insurance card, we can use the hash functions, or while designing the file signatures. So digital signature is one of the most common example of the hashing. Okay, so SHA or whatever our URL, that is HTTPS. So in HTTPS also, we are just using the SHA algorithm to secure the our URLs. Okay, so these are the some most commonly used examples where we can able to use this particular hashing concept or hashing data structure. So inside the hashing, only three things are required. One is hash table, second one is key, and the key that can be just stored inside the hash table by using the hash function. So there are the four types of the functions we have just seen: division, mid square, folding, and one more, that is multiplication. Okay, so these are the four techniques, and after that we can able to see the different collision avoiding technique. So open addressing and chaining. So open addressing includes again four techniques: linear probing, quadratic probing, rehashing, and double hashing. So each and every technique having the example. Okay. And inside the chaining, we directly use the linked list to chain the particular concepts. So these are the two techniques related to the static hashing. So inside the dynamic hashing, we just use the two techniques. Again, dynamic hashing with directories and without directories. So these are the particular concepts which are included inside the hashing. Okay. So any doubt up to this?
No, sir.
No, sir.
Okay. So just write down the questions related to this particular unit.